The world's largest companies, Google, Amazon, Microsoft, are all captives of a single supplier for their most vital resource, the computational power of AI. This is the trillion-dollar paradox engineered by NVIDIA CEO Jensen Huang. It's not luck. It's a deliberate, decades-long business strategy that pivoted the company from a gaming graphics pioneer to the singular, indispensable architect of the modern AI economy. You can see the shift reflected in the numbers. In fiscal year 2025, NVIDIA's data center revenues surged by a staggering 142% to $115.2 billion, while the legacy gaming segment barely moved at 9% growth. This staggering disparity confirms a calculated, strategic abandonment of the past for future, hyper-dominant control. The market sees this clearly, valuing NVIDIA at a substantial premium because they understand the company possesses an unbreakable, full-stack moat. The foundation of this dominance was laid in 2006, years before the deep learning revolution, with a single, colossal bet on accelerated computing. Huang foresaw that the future was not the CPU, but the parallel processing engine of the GPU. This vision led to the creation of CUDA, a proprietary software platform, the invisible prison of code. Today, every major AI framework, from PyTorch to TensorFlow, relies on CUDA deep within its architectural DNA, supported by 2 decades of optimization and continuous development. This ecosystem maturity creates devastating switching costs. You can build a rival chip, but migrating away from CUDA means rewriting massive amounts of code, dealing with systemic headaches, and risking performance loss, often rendering any hardware discount irrelevant. Huang then made a masterstroke to control the entire computing environment. The 2020 acquisition of Mellanox for $7 billion. Mellanox provided InfiniBand, the low-latency, high-bandwidth plumbing, essential for high-speed communication between thousands of GPUs in massive AI clusters. By owning the processor GPU, the software CUDA, and the interconnect, InfiniBand and NVLink, NVIDIA achieved complete architectural control. This allows them to sell the DGX SuperPOD, a turnkey, pre-optimized AI supercomputer that guarantees maximum performance and superior total cost of ownership, TCO, at scale, effectively locking large enterprises into the full NVIDIA stack. This full-stack strategy has placed the cloud titans, AWS, Google, and Microsoft, in a perpetual crisis. They all pursue a dual strategy. Strategy A is buying billions of dollars of NVIDIA chips to meet immediate customer demand, exemplified by the massive AWS deal with OpenAI for GB200 and GB300 chips. And strategy B is building custom chips like TPUs or Trainium. But strategy B keeps hitting the CUDA wall. Because Google's TPU stack lacks the universal flexibility and ecosystem maturity of CUDA, customers are forced to rely on NVIDIA hardware now. Furthermore, NVIDIA leverages this scarcity by prioritizing high-demand chips to smaller, emerging cloud providers, pressuring the big three to maintain enormous, high-margin purchase commitments or risk losing market share, thereby reinforcing the dependence paradox. The final piece of the strategy is expansion into physical AI. NVIDIA is now applying the same lock-in strategy to robotics, building a second-generation moat around the Omniverse simulation platform. By providing the definitive environment for training and testing physics-accurate AI models, which are then deployed on the Jetson Edge hardware, NVIDIA ensures that the entire life cycle of future autonomous systems, from factory floors to general-purpose humanoid robots, is dependent on its full-stack architecture. This is how Jensen Huang outsmarted the world, by selling not just a component, but the entire operating system of the future economy.